Welcome back. In this teaching video, I'm looking at 10.5 connected particles. 10.5 represents chapter 10, section 5 of the Pearson A level maths applied maths year 1 textbook. Let's have a look at the key facts of this section. You can solve problems involving connected particles by considering the particles separately or if they are moving in the same straight line as a single particle. Let's move on to the modeling assumption of a light object. The tension or the thrust is the same throughout the object. Finally, the modeling assumption of an inextensible object. Acceleration of the connected particles moving in a straight line is the same. These are the key facts of 10.5 connected particles. I'll be implementing these key facts within 4 exam style questions. Here is exam style question 1. A lorry of mass mkg is towing a trailer of mass 3 mkg along a straight horizontal road. The lorry and trailer are connected by a light inextensible tow bar. The lorry exerts a driving force of 50,000 newtons, causing the lorry and trailer to accelerate at 5 meters per second. The lorry and trailer experience resistance of 4,000 newtons and 10,000 newtons respectively. Part A, find the mass of the lorry and hence the mass of the trailer. Let's have a look at the solution to part A. I'm going to start by drawing a force diagram. Here is my force diagram. So I've got a horizontal surface, I've got a trailer, and I've got a lorry. The mass of the lorry is mkg and the mass of the trailer is 3 mkg. The lorry is in contact with the horizontal surface, so the horizontal surface will exert a normal reaction acting vertically upwards on the lorry. So here is the normal reaction. I can label it as RL, normal reaction of the lorry. In the same way, the trailer is in contact with the horizontal surface, so the horizontal surface will exert a normal reaction on the trailer, acting vertically upwards. I can label it as RT, the normal reaction of the trailer. Both particles are connected by a light inextensible tow bar. Let's create a split over here so that we can look at the forces acting on the lorry separately and the forces acting on the trailer separately. Let's start with the forces acting on the lorry. We've got the normal reaction. We also have the weight of the lorry acting vertically downwards. This is given by mg, where g is the acceleration due to gravity. G is equal to 9.8 meters per second. Now, the lorry and trailer experience resistance of 4,000 newtons and 10,000 newtons respectively. So suppose that this entire system is accelerating to the right. Okay, so we can label the acceleration. And that acceleration is 5 meters per second. This means that the resistance has to act to the left in the opposite direction of motion. So the resistance for the lorry, ladies and gents, it is 4,000 newtons acting to the left. Okay, since this entire system is moving to the right, the tension in the tow bar will act to the left for the lorry. Let's call it T. Okay. The lorry exerts a driving force of 50,000 newtons. Okay, so there's a driving force acting to the right of 50,000 newtons. So that there, ladies and gents, is all the forces acting on the lorry. Let's move on to the trailer. We've got the weight of the trailer acting vertically downwards. This is given by 3mg. Again, g is acceleration due to gravity. G is equal to 9.8 meters per second. Now let's have a look at the tension in the tow bar for the trailer. Using Newton's third law, for every action there's an equal but opposite reaction. So since there is a tension acting to the left for the lorry over here in the tow bar, the tension for the trailer will act to the right in the tow bar. Okay. The lorry and trailer experience resistance of 4,000 newtons and 10,000 newtons respectively. So 10,000 is the resistance on the trailer acting to the left. So I can label this resistance as 10,000. That there, ladies and gents, is the complete force diagram. Nice, solid. So I've got my force diagram drawn. I can now proceed forward and do some calculations. But before I start my calculations, again, I would like to highlight the importance of creating the split in the middle. This split helps me identify all the forces acting only on the lorry and all the forces acting only on the trailer. Let's have a look at the solution to part A. Find the mass of the lorry and hence the mass of the trailer. So we are trying to work out the value of m and the value of 3m. To do this, I'm going to consider the system as a single particle to eliminate the need of working out the tension, T. This will become more clear shortly. So consider the system as a single particle. So I'm going to resolve horizontally, taking right to be the positive direction, and to generate the equation of motion, I'm going to use Newton's second law, F equal ma. So F equal ma. I'm going to start by working out the resultant force F. So this would be 50,000 acting to the right, minus T acting to the left, minus 4,000 acting to the left, plus T acting to the right, minus 10,000 acting to the left. So that is the resultant force F. This must equal the combined mass, which is 3m plus m, 4m, multiplied by the acceleration, which is 5 meters per second per second. Okay, so the minus T and the plus T cancel out. We've then got 50,000 minus 4,000 minus 10,000. This is equal to 3,600. So 3,600 is equal to 20m. Hence now we can work out what m is. M is equal to 3,600 divided by 20. M is equal to 1,800. Now we can work out 3m. So we do 3 multiplied by 1,800, which is 5,400. Therefore, the mass of the lorry is 1,800 kilograms. The mass of the trailer is 5,400 kilograms. And that there completes part A of exam style question 1. Moving on to part B of exam style question 1. Find the tension in the tow bar. Let's have a look at the solution to part B. So in part B, the target is to work out the value of T, which is the tension. Now to find the value of T, I can either resolve for the trailer or resolve for the lorry. In both cases, I'll get the same answer. Suppose I resolve for the trailer. So I can write down consider trailer. So I'm going to look at all the forces acting on the trailer, hence why we've got a split here. We can delete the lorry, only focus on the trailer. I'm going to resolve horizontally, taking right to be the positive direction, and to generate the equation of motion, I need to use Newton's second law. F equal ma. So my first step is to work out the resultant force F acting on the trailer. So I've got T to the right, take away 10,000 to the left. This must equal the mass of the trailer. So that would be 3m, which is 5,400, multiplied by the acceleration, which is 5. So I've got minus 10,000 is equal to 27,000. Hence T, the tension, is equal to 27,000 plus 10,000, which is 37,000 newtons. That there, ladies and gents, is the answer. Let me check that this is correct by resolving for the lorry. I should get the same answer. So suppose now that I consider a lorry. I'm going to be resolving horizontally, taking right to be the positive direction, and to generate the equation of motion, I'm going to use Newton's second law, F equal ma. So what is the resultant force F acting on the lorry only? So this would be 50,000 to the right, take away 4,000 to the left, take away T, equal to the mass of the lorry. So the mass of the lorry is 1,800 kilograms, multiplied by the acceleration, which is 5. So I've got 46,000 minus T is equal to 9,000. So T must equal 46,000 minus 9,000. Okay, so T is equal to 37,000 newtons as required. As you can see, in both cases you get the same value for the tension acting in the tow bar. And so that there completes part B of exam style question 1. Let's have a look at part C of exam style question 1. Explain how the modeling assumption that the tow bar is light and inextensible affect your calculations. So in part C, let's begin with light. The modeling assumption is that the tension is the same throughout the tow bar. Then we've got inextensible. The modeling assumption is that the acceleration of the trailer and the lorry connected by the tow bar is the same. And that there, ladies and gents, completes exam style question 1. Moving on to exam style question 2. Two particles A and B of masses 10 kg and 5 kg respectively are connected by a light inextensible string. Particle B hangs directly below particle A. A force of 180 newtons is applied vertically upwards, causing the particles to accelerate. Part A, find the magnitude of the acceleration. Before I begin the solution to part A, I'm going to draw a force diagram to illustrate this exam style question. We are told that particle B hangs directly below particle A. So particle A is on top and particle B is at the bottom. The two particles are connected by a light inextensible string. I'm going to draw a split in the middle so that I can identify the forces acting separately on A and the forces acting separately on B. Let's start off with A. Now we are told that a force of 180 newtons is applied vertically upwards, causing the particles to accelerate. So I can label 180 newtons acting vertically upwards, causing the particles to accelerate upwards, and this acceleration I can call it A, meters per second per second. The mass of particle A is 10 kg, hence the weight of particle A is 10 g acting vertically downwards. Since particle A is accelerating upwards, the tension in the string for particle A acts vertically downwards. I can call it T. So these are all the forces acting on particle A. Let's move on to particle B. Now, since the tension in the string T for particle A is acting vertically downwards, by Newton's third law, for every action there's an equal but opposite reaction. For particle B, we have tension acting vertically upwards. The mass of particle B is 5 kg, hence the weight of particle B is 5g acting vertically downwards. That there, ladies and gents, is a complete force diagram illustrating this exam style question. Nice, solid. So we've got a force diagram. Now I can proceed with the calculations. Part A, find the magnitude of the acceleration. So let's have a look at the solution to part A. Now for part A, I'm going to consider the system as a single particle to eliminate the need of working out the tension, as you will see shortly. So consider the system as a single particle. I'm going to resolve vertically, taking upwards to be the positive direction. Okay, so I'm going to resolve in the direction of acceleration. To generate the equation of motion, I need to use Newton's second law, which states that F is equal ma. Let's start by working out the resultant force F. So I've got 180 acting upwards, minus 10g acting downwards, minus t acting downwards, plus t acting upwards, minus 5g acting downwards. This is equal to the combined mass. So the combined mass will be 10 plus 5, which is 15. 15 multiplied by the acceleration A. Now, as you can see over here, ladies and gents, the t's will cancel, so the minus t plus t cancel. Okay, so we have 180 minus 15g is equal 15a. So now I can make A the subject in order to work out the acceleration. So I've got 180 minus 15g divided by 15 is equal to A. I can substitute g equal 9.8 into the fraction, and if I do this, I get A is equal to 2.2 meters per second per second. So that there completes part A of exam style question 2. Moving on to part B, Find the tension in the string. Okay, so let's have a look at the solution to part B. Now, to work out the tension T, I can either resolve for particle A or resolve for particle B. In both cases, I'll get the same value of T. So I'm going to consider particle B. So consider particle B. Right, so I'm going to resolve vertically, taking upwards to be the positive direction, and to generate the equation of motion, I'm going to use Newton's second law, which is F equal ma. Okay, so we've got a split there for a reason. Let's neglect particle A. Let's only focus on the forces acting on particle B. So I want to work out the resultant force F. That would be T minus 5g. So I've got T minus 5g. Okay, so the mass of particle B is 5. Multiplied by the acceleration, 2.2. So I've got T minus 5g is equal to 11. Hence T is equal to 11 plus 5g. Now I can substitute g equal 9.8, and if I do this, I get T equal 60 newtons. And that completes exam style question 2. Ladies and gents, I'm now going to look at a lift problem. Exam style question 3. A lift of mass 10 kg accelerates upwards at 0.5 meters per second, pulled by a light and extensible vertical cable, carrying two crates A and B, which have a mass of 1 kg and 2 kg respectively. Find part A, the tension in the cable. Let's have a look at the solution to part A. The tension in the cable acts vertically upwards. It is affected by the weight of the lift, the weight of crate A, and the weight of crate B. In part A, we are going to consider the lift. So part A, consider lift. So here is the lift. The tension in the cable acts vertically upwards. The mass of the lift is 10 kg. The mass of crate A is 1 kg and the mass of crate B is 2 kg. Hence the combined mass is 13 kg. So the combined weight is 13g, acting vertically downwards. The lift accelerates upwards at 0.5 meters per second. Okay, so now to work out the tension T, I'm going to resolve vertically, taking upwards to be the positive direction, the direction of the acceleration. To generate the equation of motion, I need to use F equal ma, Newton's second law. So the resultant force F will be T acting upwards minus 13g acting downwards. So we have T minus 13g equal to the combined mass, which is 13, multiplied by the acceleration, which is 0.5. So we have T minus 13g is equal to 6.5. Hence T is equal to 6.5 plus 13g. So if I substitute g equal 9.8, I get T equal 133.9 newtons. This completes part A of exam style question 3. Moving on to part B of exam style question 3. Find the force exerted on B by A. So in part B, we have to consider crate A because it says by A. So part B, consider crate A. So here is crate A. The mass of crate A is 1 kg, hence the weight of crate A is 1g acting vertically downwards. Crate A is in contact with crate B, so crate B will exert a normal reaction on crate A, acting vertically upwards. Let's call this RA. The entire system accelerates vertically upwards at 0.5 meters per second. Okay, now let's try and understand part B. It says find the force exerted on B by A. Okay, now for A to remain on B as the lift accelerates vertically upwards at 0.5 meters per second, there has to be a force equal to RA acting in the opposite direction. So essentially, to find the force exerted on B by A, we need to work out RA. Okay, so I'm going to resolve vertically, taking upwards to be the positive direction of acceleration, and to generate the equation of motion, I need to use F equal ma, Newton's second law. So the resultant force F will be RA acting upwards minus 1g acting downwards. This has to equal the mass of crate A, which is 1, multiplied by the acceleration, which is 0.5. So RA minus 1g is equal to 0.5. Hence RA is equal to 0.5 plus 1g. Okay, now I can substitute g equal 9.8 into here. So if I do that, I get RA is equal to 10.3 newtons. Therefore, the force exerted on B by A is 10.3 newtons acting downwards. And that there completes part B of exam style question 3. Moving on to the final part of exam style question 3, part C. Find the force exerted by B on the left. So we want to work out the force exerted by B. So in part C, we have to consider the crate B. Okay, so let's have a look at the solution to part C. Consider crate B. So I've got crate B. The mass of crate B is 2 kg, hence the weight of crate B is 2g acting vertically downwards. The force exerted on B by A was 10.3 newtons. So that also acts on B vertically downwards. Because crate B is in contact with the floor of the lift will exert a normal reaction on crate B, acting vertically upwards. We can call this RB. The entire system accelerates vertically upwards at 0.5 meters per second. Now let's try and understand part C. Find the force exerted by B on the lift. Okay. Now, for the crate B to remain on the floor of the lift, as the lift accelerates upwards at 0.5 meters per second, there has to be a force equal to RB acting in the opposite direction. So essentially, to find the force exerted by B on the lift, we are trying to work out the normal reaction of B. In other words, we are trying to work out RB. Okay, so I'm going to resolve vertically, taking upwards to be the positive direction, which is the direction of the acceleration. And I'm going to use Newton's second law to generate the equation of motion. The resultant force F will be RB minus 10.3 minus 2g. So we've got RB minus 10.3 minus 2g equal to the mass of crate B, which is 2. Okay, so we have mass which is 2 of crate B multiplied by the acceleration, which is 0.5. Okay, so I've got RB is equal to 1 plus 10.3 plus 2g. And if I substitute g equal 9.8, I get RB is equal to 30.9 newtons. So now I can write a conclusion. Therefore, the force exerted by B on the lift is 30.9 newtons acting downwards. And that there, ladies and gents, completes exam style question 3. Solid. Moving on to exam style question 4 on scale pan problem. A scale pan of mass 2 kg is attached to a light and extensible vertical string. The scale pan carries two weights A and B. The mass of A is 400 grams and the mass of B is 600 grams. A rests on top of B as shown in the diagram. The scale pan is raised vertically using the string with acceleration 0.8 meters per second. Find part A, the tension in the string. Let's have a look at the solution to part A. The tension in the string acts vertically upwards. It is affected by the weight of the scale pan, the weight A and the weight B. So for part A, we are going to consider the scale pan. Consider scale pan. Okay, so we have the scale pan. The tension in the string acts vertically upwards. The mass of the scale pan is 2 kg. The mass of A is 0.4 kg and the mass of B is 0.6 kg. Hence, the combined mass is 3 kg. So the combined weight is 3g acting vertically downwards. The system accelerates vertically upwards at 0.8 meters per second. Now I'm going to work out the tension in the string by resolving. So I'm going to resolve vertically, taking upwards to be the positive direction, the direction of acceleration. To generate the equation of motion, I'm going to use Newton's second law, F equal ma. So the resultant force F will be T acting upwards minus 3g acting downwards. So T minus 3g has to equal the combined mass, which is 3 kg, so 3 multiplied by the acceleration 0.8. So I've got T minus 3g is equal to 2.4. Hence T is equal to 2.4 plus 3g. I can substitute g equal 9.8, and if I do this, I get T equal 31.8 newtons. That there, ladies and gents, is the tension in the string. And this completes part A of exam style question 4. Juice. Moving on to part B of exam style question 4. Find the force exerted on B by A. So it says by A, hence in part B we have to consider A. Part B, consider A. So we've got A. The mass of A is 0.4 kg, hence the weight of A is 0.4 g, acting vertically downwards. A is in contact with B, so B will exert a normal reaction on A, acting vertically upwards. We can call this RA. The entire system accelerates vertically upwards at 0.8 meters per second. We want to find the force exerted on B by A. For A to remain on B as the scale pan accelerates upwards, we must have a force equal to RA acting in the opposite direction. Hence, the force exerted on B by A is essentially the normal reaction of A. We need to work out RA. So I'm going to resolve vertically, taking upwards to be the positive direction, and I'm going to use F equal ma to generate an equation of motion. The resultant force F will be RA acting upwards minus 0.4 g acting downwards. So I've got RA minus 0.4 g equal to, the mass is 0.4, multiplied by the acceleration, which is 0.8. So I've got RA minus 0.4 g is equal to 0.32. So RA is equal to 0.32 plus 0.4 g. Now I can substitute g equal 9.8, and if I do this, I get RA is equal to 4.24 newtons. Therefore, the force exerted on B by A is 4.24 newtons acting downwards. And that there, ladies and gents, completes part B of exam style question 4. Moving on to part C of exam style question 4. Find the force exerted by B on the scale pan. So it says by B. In part C, we have to consider B. So part C, consider B. Here is B. The mass of B is 0.6 kg, hence the weight of B is 0.6 g acting vertically downwards. The force exerted on B by A was 4.24 newtons, so we also have 4.24 newtons acting on B vertically downwards. B is in contact with the floor of the scale pan, so the floor of the scale pan will exert a normal reaction on B acting vertically upwards. We can call this RB. The entire system accelerates vertically upwards at 0.8 meters per second. We want to find the force exerted by B on the scale pan. Now, for B to remain on the floor of the scale pan as the scale pan accelerates vertically upwards, we must have a force equal to RB acting in the opposite direction. So essentially, the force exerted by B on the scale pan is RB. We want to calculate RB. So I'm going to resolve vertically, taking upwards to be the positive direction, and I'm going to use F equal ma to generate the equation of motion. The resultant force F will be RB acting upwards, minus 4.24 acting downwards, minus 0.6 g acting downwards, equal to, the mass is going to be 0.6 multiplied by the acceleration, which is 0.8. So I've got RB minus 4.24 minus 0.6 g is equal to 0.48. So now I can rearrange. RB is equal to 0.48 plus 4.24 plus 0.6 g. I can substitute g equal 9.8, and if I do this, I get RB is equal to 10.6 newtons. Okay, so over here, we can write a conclusion. Therefore, the force exerted by B on the scale pan is 10.6 newtons acting downwards. That there, ladies and gents, completes exam style question 4 and this teaching video 10.5 connected particles. If you found this teaching video useful, please don't forget to subscribe, leave a like, leave a comment, turn on your notification bell so that you receive notifications every time I post a new teaching video.